Today I will make a demo, backward demo. So I start from a finished manifold, explaining a bit of the assembly and machining drawing, and then go back to the beginning of this manifold that we see, and we'll understand how to design efficiently with, in this case, I will start by loading a HydroCAD schematic. So this is the manifold that we are analyzing today. A few short description about MDTools environment and characteristic. As we can see, in this case, we have a lot of cavities. Some are ports, bolt holes, or cartridge cavities. This is a mobile manifold. On the right, we have a PVG interface, mobile sectional valve. We have some cartridge valves, and we have external ports, and also on the other side we have other external ports. A few description about the environment. Not all the attendees have already been used in MDTools, so let me explain a bit how the system works. We can see a lot of colors. Each color is assigned to a net. So MDTools browser on the left is showing the cavities that we have in our manifold, and we can also switch to nets. Net is a list of connecting cavities. This A1 is a very short net, is the orange. It is just connecting A1 port with PC port 1. As you can see in MDTools, we have the possibility to isolate nets, and this will help to visually understand how we have made the connection. This is our PNet. If we compare a manifold with a diagram, and now I have the diagram with me, that PNet let me run the export to MDTools interface. That PNet that I am isolating here is the same that we have represented there. So for MDTools and for HydroCAD, a net is a list of connected cavities belonging to different components. And physically in our block, this net will be represented with one color. Our block has several nets. And now let me switch back to show all colors, show all nets. As you can see, we have a lot of drill holes and ports all connected together to match that hydraulic diagram. MDTools has a specific command to verify if we made a good job in our design. So this design has been made starting from a hydro diagram. So in this tab, hydro schematic, we can look that we have loaded a diagram. We have a list of components and external ports, no orifice plug here. Each component is grayed out. It means that all the components are present in our manifold. And we have one command that is called schematic check. This command helps us with comparing the block that we have designed here with the schematic that we have imported. By running the schematic check, we can see the differences between our component and our block. If we run the wall thickness check, I'll jump later when we start designing. I will jump to the differences between the diagram. If we run the wall thickness check, which is now the second command that we want to study here, we do a wall thickness check maybe for 4 millimeters around all block, and we can start it. And as you can see here, we have a list of potential errors in our block. So we have clearance between cavities. The clearance can be within the same net. In this case, it is between a plug 9 and PC 2 port 2. So in this case, it is a clearance between the two drills that are in the same net. So that's not really a problem. This is this clearance here. And in this case, when we see PCD, D stays for that area, and it is this clearance here. between always our plug 9 that is coming through here and with the dead area of the cavity. So in this way, with one command only, we can verify if we have issues for wall thickness in our block. Ideally, at the end of our design, we want to not have any issue in the wall thickness, or we control and we verify that this is not an issue for safety in our block. The third check that we are going to run now is the connection check. Connection check is able to find if we have mistakes in our connection. And in this case, there are no issues at all, so this list is empty. And this is the most important check that we make in a block. When I jump again to the design in about 10 minutes from now, we will understand and we will run this connection check again in order to better understand how it works. This month, we have also planned a specific webinar that will guide you through all the checking in great details, so we understand not only these 3 checks that we have run now, the schematic, the wall thickness, and the connection, but we will look also the manufacturing check, the connection offset, the pressure rating, and some other checking that we have in MDTools. So if you are interested, you can sign up to the next webinars for MDTools. So now let's say that this block is okay, and I want to assemble it, and later I want to create a machining drawing for it. So when it's up to making an assembly, in this case, I'm using Inventor, but MDTools is a plugin also for SolidWorks, so it works a similar way, and it has a lot of commands that we use for the design, and they are very similar between the two interfaces. In Inventor, I will create an assembly, AIM file. In SolidWorks, it will be a SolidWorks assembly. No difference in terms of workflow. MDTools has some commands in the assembly, and if you start from a hydro diagram, this command, the first one, automatic assemble, will work. And this is what I want to show you now. I'm not explaining how to make it work. You must have HydroCAD, and there will be other webinars explaining really deeply the interaction between Hydro and MDTools. This is what really can happen. When you run auto assemble, you click yes. It will ask for the block, and my block is exercise 1, and I will open it. And now MDTools will automatically take all the plugs and the components because they are linked in the diagram that I have imported in my manifold design. So as you see on the left, we have the browser populating for components. And our block is automatically assembled. In case of solenoid valves, we have the possibility to manually rotate the coils, or we can add constraints with the Inventor or SolidWorks command. As you can see, I was able to automatically create a manifold assembly of my block just within few seconds by running the automatic assemble command. Even if you don't start with HydroCAD, there are 2 commands that will work, and they are called component assembly and plug. Plug will just add all the construction plugs. So if I get rid of all the plugs in my assembly and click plug command will put all the expander or BSP or short port or whatever it is in the block in the correct position. While a component will provide me a list of all the cavities available in the block. We have the possibility to filter by cavity type. We can sort by cavity name, component ID. And for instance, we want to add some fits to all the 3x8. So we select all the 4 3x8. We click select cut files. And if you know the folders where the fitting is located, you can just select it, move to the right and click OK. Then you go to the second G1 by 4. If you know the file name, you just search by file name You can view a preview of the 3D model and move to the right. And also for the P, we select the G1/2. When we have mapped all the components, we can just click Update All. And MDTools will bring all the correct component. I also noticed that I don't have the component for the relief valve here. So let me just manually assign it, component. I take the RV, select CAD file, and that was a HIDAC DB10P. And also I link fitting G1/2 and update. And now my assembly is completed. The assembly is an AIM file, and you can export to step file. This command called shrink wrap will create a simplified 3D model that you can share with your customer. It will remove all expander plugs, all plugs, all not needed geometry, and will create a clean model that you can share with your customer. Now let's move to the machining drawing. So let me save this assembly. And let me close the assembly environment. Before creating the machining drawing, I run one command that is called machining ID. Machining ID will be able to assign to any cavity in the block. So as you see here, let me do one step back. In the model browser, we have a list of all the cavities, and the cavity name like B1, EV1, P, plug 1, plug 2, PVG32. Those normally, and for MDTools, they are called component IDs, and normally they match what is in the diagram. EV1, RV, EV2, PR, port B2, and so on. But this text, this component ID may not have a meaning for a vendor making the machining drawing or making the manifold. When we create a machining ID, we want to assign to each cavity in the block a unique ID. You have several rules available. And in this case, I want to give a number for the face, a number for the cavity, and the letter for identical cavities in the same face. When you click OK, MDTools automatically will give to each cavity in the block a machining ID. If we edit this cavity, we can see that this is component A1. The machining ID is 109. 1 stands for phase 1. 09 is the ninth operation in this phase. So when we run this, normally this is required if your machining drawing is using drill chart. And I'll show you in a minute how this is working. To make a machining drawing, we create use IDW or DWG for Inventor or solid drawing for SolidWorks. We create a new file, and we go to MDTools menu, and we create views and select the block. We selected the projection type. I am based in Europe, and also I want to thank you all the European guys that attend at 10 p.m. To this webinar. A special thank to them. And so this command will create all the views, 6 views of the block. If we zoom a bit, we can see that there are some inclined drills, and MDTools will add an arrow showing the direction for the inclined drills. In addition to that, we can display the machining IDs. When we click show machining IDs, MDTools will show next cavity also the ID. As you see, there are some colors. I use different layers in my DWG drawing, but if you don't want to use color, you can also highlight construction plugs by clicking construction port. This will add a cross to each cavity that has to be plugged. We can automatically add all the dimensions to the cavities. in each views. And now, well, we have a PVG interface. It makes sense to display the port name. So with footprint, we click OK. And in this case, MDTools will add an outline for the PVG interface and will add also the port name. And you can move the text if this is overlapping with some other entities. Close. The drawing is almost complete. We miss the machining chart, which is made automatically. You can customize it. I use this style, which is compact. I like to group identical cavities in a drill chart. So by clicking Insert in Drawing, and I just select the start point and end point for the drill chart to be positioned. And this is our drill chart. As a table, you can break it, so you can right click, and those are standard commands in the CAD application. We can break it into two. And as you see, machining, let's check some of them. ID 101, it's a drill 3 meter, 50 depth, and alpha and beta. There are some expander. There are some HIDAC cavities, HIDAC FC8H3. Bottom drill is 13 by 53, and the spot face is 25 by 1, and so on. So this drill chart is detailing each information for each cavity. If you don't like drill chart, you can create the machining callouts. This can be done automatically on all the cavities in the block by running create. And in this way, MDTools will add all the machining callouts. And what you do is only you move all the text around in order not to overlap. Normally, a machining, the drill chart drawing is much easier because you really don't need to rearrange all the information. This kind of drawing with machining callout is easier to read for the vendor. So I see it frequently used by MDTools customer. So basically, designer needing this kind of drawing will not create the drill chart, will only create machining callouts and will move the machining callout text all around. The information that we find in each machining callout is the same that we have in the drill chart. There is no difference at all. So simply it is arranged in a different way. The advantage for the drill chart is that really it can be made compact and you can group by quantity. For instance, here we have the M8 for the PVG interface. So we have 3 M8 with a bottom drill and the depth for the M8 thread. In addition to that, we can extract a cavity list. So this can be helpful to get a list of tools that needs for the manufacturing of this block. We have a list of all the cavities that we have and also how many of these cavities. So we have 9 expander 073, 08, 1 FC10-3 and so on. We can have a list of engravings. This is in the form of a table. So which text, where it is located, X and Y position, if it is rotated, font and height. So this information can be used to help with engraving in the machining. There are some other options that we have here, but I leave for another webinar where we will speak about more in detail about machining drawing. And now I want to get back to the design because, of course, we have started from a finished block, but I want to give you the feeling how easy it is to create such a manifold block. So let me close this part. And let me start from the beginning. So normally we start from a diagram, and as you see, I have my diagram made with HydroCAD. And when you use the export to MDTools interface, what you need to do is just export this file and you save it in a location. Let me put in my desktop, and that's webinar 2. Information of the diagram are including engraving, port information, so which net is linked to each port in a component, CAD file. This is where the information for the automatic assembly is coming through. So in this case, I have a cartridge and 2 coils. And of course, I have a cavity name. This is the most important because we have no possibility to export to MDTools missing information. At least we must have a cavity name. Technically, the cavity name could even be wrong, and then MDTools would ask us to map a correct cavity. But you cannot export to MDTools missing information. So as you can see here, we can isolate nets, we can check our diagrams, and we just export to MDTools. When we are in Inventor or SolidWorks in the MDTools, we go to the Hydro schematic and we load our diagram. It was saved in the desktop and it was called Webinar 2. Now, before starting our design, now MDTools is reading the XML file and will provide us on the left a list of cavities, component and orifice plugs. If we go to the settings, here we can see which library we're using. I'm using my standard library for designing. Those are standard cavity color, and we understand what a net is. So a net A1 will be orange, B3 will be net 7, P will be red, P1 will be orange, and so on. You can create your custom net names, and always when you use those net, they will get that color. But MDTools will give you also flexibility in terms of color. Under exports, today I want to design with the expander, so I just delete and load the expander plugs. So you can change which plug family you want to have in your design. So now there is a specific command called export that will always read the from this list. So will suggest me a size for expander in this list. Apply and close. Now we create our block. In this case, it's a block fitting a PVG, so the size should not be large. So 120 by 120, and let's make it 200, and maybe later we will reduce a bit. So in this case, I start from the PVG interface. I click Insert, touch my face. I can see a preview, and I position it where I want. Okay, this cavity will be placed, and we will see all the colors for that cavity. We can see the engraving, PVG32. We can see different colors. So dark gray means that this drill was not used in the diagram. And you have different options. In this case, you can delete or suppress the cavity if you don't need them. This for the PVG is the second tank. Let's say that I don't need for this design, but sometimes you can use it. So if you delete all the cavity, then it will delete everything, but you can delete just single drills, not needed. If you don't like the position for the PVG, and you can just move it and change the location for the engraving. Now I can see I have this PVG32 has been grayed out, so I can double click and place other components in my face. Okay, and another one, and place maybe here, and I can define a position from another cavity that is in the block. Maybe I keep 45, 0. As you see, the component is coming with colors, and engravings automatically. Same color means the cavity must be connected together. And we can also have a different approach. We can go by net. Going by net is a good, really a good strategy, because it will help you concentrating on the complex part of the diagram instead of just filling all the components. So now I want to connect all the components linked to the P-net. I take my P port and I position it maybe on the opposite face and maybe in the center of the P port at 0, 0. I stretch this drill and stretch again, stretch, take the drill and connect it this way. We need to connect all the red ports. So we make a construction plug on port number 3, which is the red one. Automatically MDTools is selecting an MD600-80. Continue, and we place the plug on the bottom face. Automatically MDTools will place this plug in the center of the cavity, and we click OK. We do the same, export and connect on port 3. Continue and place it here. As we can see here, these drills are not touching or not touching properly. So I use just a command called move multiple. I move the entire footprint just maybe on the Z direction, 1, 2, 3, 4, 5 millimeters. So now there is a better intersection here. The tank line is correct. So let me just stretch the tank line here. And as we see, this is already connected. But if we want a better connection, we can use the connect cavity command. We touch the cavity. I'm sorry, we touch the cavity. Let me save this X2. Okay, looks like I have okay, doing a different way. I'm sorry for the inconvenience. So I stretch this drill and make it this way. There is a command called bend that can automatically fix all the intersections in the block. Bend, it will scan through all the cavities. And for instance, in this case, it found out that the PVG32 tank is 109 millimeter deep, but to make a good connection with this cavity, 78 is enough. We can trust it and make update all. This command will fix all the intersection in the block very, very easily. Also, in this case, it will make a good intersection between the two drills. If our block is too large, we can stretch it. We can just make it, let's say, 135. By color, we go back to the schematic and we take the B1. Let me start going a little faster. I touch the face and connect with port number 4. Okay. And I take the B2, touch, and connect with port number 4. The engraving by default goes bottom, and so in this case it's going out of the manifold, so we just change the position. There are commands to align engravings, but of course in this case that's not enough. We need to move it on a different location. We can go on and say A2 is here, we take it and position here and connect to port number 2. And A1, we have the PO check. So let's insert the PO check and we place it maybe here. And by looking at the colors, we can see that A1 is our port that has to be placed on top here. and we can connect to cavity port 1. In the center, maybe we move it slightly here, and we can use just a 10 millimeter diameter. Anytime during the design, we can do the connection check. Connection check means MDTools will look at what we are doing in the block, and will let's not use the poor connection lead. I'll explain later what it is. We start, and as you see, we have a list of issues in our block. In this case, we just have open nets. So A11 is a net and it's open. B1 is also open. LS is open. So not all the diagram has been all the connection have been made. This is also listing potential errors. So for instance, if my drill, instead of being in this position, let me move it this way. So if our drill, instead of being here, it was hitting the other drill, then the connection check will find errors. So in this case, it is finding that A2 is connecting with the bolt hole directly. So, and this is really an issue. So in this case, we just want to align this cavity with this one. And also let me just do a connection again with port number 2. Okay. Now let me take the tank line. I take the T port and place here. And I want to connect with the blue line, port 1, in the center. And I see there is this vertical drill. So we can use another technique. In this case, we can keep 5 millimeters from this drill with following pattern. So we can go on this side, on the other side. And if needed, we can also add some extra MMs. And now we have made the connection. I need to connect brown net. So let me create an external construction port on port 2. Continue and place on this face. Click OK. And also copy this one on top face and connect with port 2. And now I connect the two. So export again between this drill and this one. Continue. I touch this face, and then MDTools will make a connection between these two. So here and here, and we'll find the intersection. Click OK, and this will make the connection. We go on. Let's see what is missing. We need the relief valve, which we can put on this position and connect with the pressure. Okay. And we want a construction port on the tank line and place on top face. In this case, if we run a connection check, we will see that we have a problem. So this is a problem. This drill is touching the expander, so we cannot damage the expander seat. Otherwise, this will be very, very dangerous. Although I honestly don't like much expander. So let me use a command that in this case may help. Replace, I may use a screw plug here. I replace and take a G1x4 plug. And I want just to have a 1 millimeter spot face depth. So in this case, there is no problem. This is a screw plug and there will be no issues at all. And also I can replace this one with the G1x4 plug. So although in my design, I had defined that I want expander plug, now I just say for these two connections, I prefer going for a screw plug. And this is working fine. I need to connect the yellow ones. So this is on the opposite side. So let me show you how easy it is to to model the manifold as you want. So I want to move multiple these cavities, and I move on the Y direction up this way. I will make my stretch this drill down. I will make a construction port down here on the bottom face. And well, this drill is too long, so let me optimize it again. Bend. You can also manually do the connections, but the bend will fix all the connections. So in this case, I see 2 connections at least. This one is long and this one also is not correct. All update, and this will fix all the connections. And erase. And I can copy this drill and place it here and connect. And I can also copy again, place on this face and connect here and with the yellow. Let me put the LS somewhere, and let's say that it is going to be here. Customer wants it to be there, and we need also the relief valve for the pilot. The pressure reducing valve, let's say that the pressure reducing is here. So now we want to make some inclined drills, and maybe with some strange inclination, dual inclination. So let me go to the cavity library and take a BSP plug, G1/8, and insert it and place it here and connect with this one. And we move it slightly here. I don't like a strange inclination for drills, but in this case, I want to go with inclination up to the tip of that drill and say, okay. Of course, this is not really something that the manufacturer will like. Also, I want to allow change for this drill. Alpha will be 180, and we can increase the okay. This will create an inclination to the drill, and we can move this up. And let me stretch this, make it slightly longer. So as you can see, I frequently use the stretch command. Stretch command is very handy because it can just be used to change the drill depth of a drill. But by allowing change, it can easily be used to make inclined drills and also dual inclination. Dual inclination means a combination between alpha and beta. For simple inclination, we keep alpha 0, 90, 180, and 270, or a mix of them to have a compound angle. So we made this strange connection. Let me make a construction plug on port 2, and let me finish this design. This is the pressure reducing valve. Let me increase a bit the spot face here. Let me make it 3 mm. So I move this by 2 millimeters. Let me connect again on port number 2. And I want to make the connection, so export between port 3 and this one on the top face. Okay. This drill, maybe we can do an align, multiple cavities, 1 and 2 with this one to have a center-to-center connection. Let us verify the connections. And we just missed the ls. All the rest is correct. We missed to connect the ls, which is here. And let me simplify a bit. Let's say that despite our customer was asking on top, I put it here because it's easier. And so I can also finish this design. Let's do again the connection check. And our block is okay. Let's verify the poor connection list and see if there are issues in terms of quality of connections. If not, I will introduce some issues. No issues, but let me explain what a poor connection is. So let's say that this drill is short. And let me color again. So in this case, the connection is there, but we are creating like an orifice here. If we do the connection check with poor connection list, this will be highlighted as a small flow. 18% of the area. So poor connection list can help with finding bad intersections in our design. And now we check also the wall thickness. I already did on the other block. Let me say 4 millimeters on all the block, and let's hope there is no much things to do. Here we have a problem, 1.1 millimeters. And yes, let me just do a connection tangent, port 2, tangent flip on the other side. And this one also, I will just change location and make it here. And we go back to wall thickness, also 4 millimeters. And again, you can go and fix other issues. Let's say that our block is okay. This is where I had started my demo. So I go to the assembly and make an automatic assembly of my manifold. I take my exercise 2. And now MDTools is assembling properly my block. So I can quickly give an idea of a manifold 3D assembly to my customer to check if it is matching in his system. All this is done very, very quickly.